Let's look first of all at Quit and Quit Chapter 13. T-test for one sample begins on page 269. So let's walk through a few things on that. And again, let me just kind of warn you, they start off with an example. That's a really good example, but again, they take you through certain things and say 3 pages later what you needed to get to where you got 3 pages earlier. So that's okay, I know that. So the question is, hang on, let me set my computer here. Okay, I've got the possibility that we may have government regulations, yes, thank you, that will say that cars have to have an average of 45 miles per gallon. So, what I'm going to do is I'm going to select a sample of cars, and I want to see if they meet that 45 mile per gallon mark. So I want to make sure that whatever my mean is, I want to see if it's significantly lower than 45. Now that tells me a couple things. One thing it tells me is that it's a one-tail test. If it's above 45, I know we're okay, even if it's significantly above 45. My question is going to be, is it significantly below 45? So I might say something like this. My research question might be, is the average mile per gallon significantly less than 45 of our sample? So I've got a bunch of cars. I know what their rated mile per gallon is. My question is that average mile per gallon significantly less than 45? So my null hypothesis might be something like, the average mile per gallon of our sample should be is not significantly less than 45. So would that be, this is a rhetorical question, the answer is yes. That would be a fairly good articulation of our research question and our null hypotheses. The question was, we can't say it's higher. No, because if it's higher, we know we meet the requirement. I just can't be significantly less. So I have, and I'm skipping ahead several pages to where I can actually see the data. Here are numbers. Oops. Here are average miles per gallon. I've got 40, 44, 46, 41, 43, 44. That really is a 4, believe me. And that gives me a mean of 43. Now, isn't that interesting? 43 is clearly less than 45, right? But we're not going to get zapped by the government unless it's significantly less than 45. So the question is, with this specific number, is 43 significantly less than 45? And I don't know. This is an example of what we refer to as a single sample t-test. A single sample t-test. Why do you suppose it's single sample? Duh. Because it's only got one sample. So what I'm doing is I'm comparing the average of data from that sample with what we call a test value of 45. There's our test value. Now, remember when we were doing the z-test a little bit ago, we got a z-value? Well, if we're doing a t-test, what do you suppose we'll get? So you all know this stuff so well already. We get a t-value. So I find out that t is equal to, has a value of negative 2.25. Now, so what, big, fat, hairy deal? Well, here's the so what, big, fat, hairy deal. Go to, okay. I plugged in a magic formula and it popped out. No, I'm going to teach you how to avoid the magic formula. If you look on page 227, I'm sorry, 277, it takes you through the magic formula. Yeah, that was kind of my response to it. Yeah. I'd sure like to not do that. Okay, let me just magically say t is negative 2.25. You believe, live by faith. No, in this case, it depends. In this case, this is the value of our t. Now keep that in mind for a minute. Don't worry about it much right now, but just kind of hold on to that and keep it in mind. Go over to page, does t mean what? The question was, does t mean test? No, I don't think so. It's probably named after some guy who's, yeah. Well, I don't know what z meant either, though, so, yeah. Yeah, no, because we're going to have other kinds of tests. Actually, we're going to have other kinds of t-tests. I should say at this point, there are 3 different kinds of t-tests. This is the first one I want to deal with. So, go over to page, again, in your Whit and Whit book, page 532. That is table B of Appendix C. Yeah, it's kind of lyrical, isn't it? Okay, now, we said our question is it less than? That means it's directional or one-tailed. So which half do you think of that page, which half do you think we're going to use of that page? Yes, that's a directional test. I left out the word then, I realize. But that's okay. Okay. So we're going to use the right half of the table. Now, look at the, it's fun to say, look at the left part of the right half. Look at the first column of that part of the table. How does that sound? Okay, what does that ask for? Degrees of freedom. So we need degrees of freedom. Our degrees of freedom, remember what degrees of freedom mean. I have 1, 2, 3, 4, 5, 6 numbers, so degrees of freedom is going to be 6 minus 1, n minus 1. So we're going to have 5 degrees of freedom. The degrees of freedom is n minus 1. How many we have in our sample? We've got 6 in our sample, so 6 minus 1 is 5. And we did a little video about why that is that way. We filled in the positions for a certain number of things we had to put somewhere. Okay, basically you've got choice 5 times, and your last one's not a choice. That's why it's the minus 1. Now I'm looking at the example. Does it tell us what kind of level of significance we're talking about here? We're going to go with the 0.05 unless it tells us otherwise. But oh, it tells us 0.01. So we're looking at an alpha level of 0.01, which is the same thing as the level of significance. So which is the next column we want to look at? I know I've got degrees of freedom as 5, so I know I'm going to look at that line that says DF is 5. But I've got 3 numbers beside the 5 to the right of it. So I go under the column of 0.01. So that tells me that my critical value, or the magic number from the table, is 3.365. So my critical value is 3.365. If I've got enough room to draw a picture here, and I don't know that I do, and I'm concerned with the lower tail, there's the shade. I'm concerned with the shaded area to the left of negative 3.365. Okay, here's where my t-value comes into play. Where is that t-value? Is it in the shaded area or the unshaded area? And the answer is that it is in the unshaded area. It's going to be over here somewhere. So, first of all, do we reject or not reject the null? We don't reject the null. Did you just guess right? Okay. We don't reject the null because it's not in the rare area. It's not in the shaded bar. It's not, as I heard you whisper, it's not significant. Which is exactly right. So therefore, 3 little dots means therefore in math language. Therefore, 43 is not significantly less than 45. Oops. Here's my answer. 43 is not significantly less than 45. Now, let's do it the easy way. Want to do it the easy way? Because I just waved my magic wand and got that t-value out of there. What I know is that the p-value is less than 0.01. That's all I know about the p-value. Wouldn't it be nice, oh yes, surely it would be, wouldn't it be nice if we could be more specific on what our p-value is? Yes, less than 0.01, that's what I care about, but wouldn't I like to know if it's 0.002 or something? Okay, I know you don't care, but humor me. Okay, all right. That's another example, another advantage of SPSS. SPSS cranks out this t-value for us. It also gives us information to more quickly interpret it without having to use the table. Because SPSS is going to give us a more specific p-value, and I just have to see if that p-value is less than 0.05 or not. So let's go back and just hang on. Let me open up, and again, you may want to follow with me if you have SPSS on your screen. I'm going to open up a blank SPSS document. I said I am, but it's not letting this do. There you go. Yeah, we're going to use this data set, but I don't have it in here yet. Now let me see if I can get that on the screen, because I think I lost that. Okay, still not showing up on your screen. Let me go back and try something else here. You're not showing SPSS on your screen yet, are you? Well, I'll show if I can ever get shared on the screen what I want to share. Yes, eventually, if I can ever get there, we are. Still not seeing it. Well, let me start over. Ah, okay, here we go. There we go. All right, you're seeing a blank SPSS document on your desktop, right? Somebody amen and tell me yes if it's okay. Oh, great, it worked. How'd that happen? It worked. All right, so we're going to enter the data in SPSS. And I'm not going to do all this table calculation mess. I am going to say that, and again, remember we go to variable view, and we have to tell it what the variable is, and the variables I'm putting are miles per gallon. So I'm going to call that very imaginatively MPG. Miles, because we're entering miles per gallon for different cars. So, and again, as soon as I enter in, as soon as I type in MPG and click off of that cell, it gives the default settings for the rest of the row in the different columns. We're going to leave that alone. So I'm going to go to data view, and what will happen is my MPG will become a column heading, and there it is. So under MPG, I'm going to put the miles per gallon we've got, and those were 40, 44, and 46. 41, 43, and 44. Okay. So I've got those pieces of data in SPSS now. Everybody with us so far? Is that in? Okay. All right. So I'm ready to analyze this. I'm ready to run my single sample t-test. So where do you suppose I would start if I'm ready to analyze? Oh, I don't know. Perhaps. Oh, you analyze? Okay, so I'm going to go to analyze. And when I click on analyze, I'm going to see some options show up underneath that. There they are. And I'm going to compare means. And I get a lot of options on the sides to compare means. And notice one of my options is a one sample t-test. Now I've been using the phrase single sample t-test. Single sample, one sample mean, the same thing. So SPSS calls it a one sample t-test. So I'm going to go over and click on one sample t-test, and it's going to open up a window with two boxes, one on the left, one on the right. the box on the left, like almost always, the box on the left is going to list every variable you've got. We have only one, so that's mile per gallon. And the one on the right, the little window, is going to, we're going to put the ones there that we want to talk about. Well, if there's only one we want to talk about, we've got only one there anyway. So I'm going to move MPG to the right box. Now, I've got another blank to fill in here, the test value. So what are we testing this mean against? What number? The number's 45. So I'm going to put 45 in the test value. Now I'm going to look and see what's under options. I think that's just going to be the default confidence interval, and it is. So, I do want to change something here. What do I want to change here? I want to make it 99 because I'm testing at the alpha level of 0.01. So 0.01 alpha level corresponds to a 99% confidence interval. So I did want to change it. Okay. So I'm going to click continue after that. And there's not a lot I have to do other than I'm just going to click OK. And as soon as I click OK, that's going to give me an output window. OK, output window. Get everybody up to speed. Gail, you got the right answer. The 45 is correct. Or you've got the 0.01. That's the right answer, but to the wrong question. Yes, 0.01 is our alpha level, but that asks for a confidence interval. So 99 was the confidence interval. All right. Notice we've got. I'm just going to circle the whole table here. I'm going to report the mean and standard deviation. Remember my t-value a minute ago? How different is it? A smidgen. That would be the technical amount, yes. It is a smidgen different. Here's the reason it's a smidgen difference. Because when they crank this thing out by hand, and when they round it off throughout the process a little more than SPSS. It's this round off error. SPSS generally is more accurate than the way WHIT does things. So there's my t-value, which is real close. There's my degrees of freedom. Now notice my significance. This says two-tailed significance. But we're doing a one-tailed test. Why do I have a one-tailed significant difference or significant value? That's because SPSS isn't smart enough to do that. Here's how you change a two-tailed p-value to a one-tailed p-value. So 2. You take the p-value it gives you and divide it by 2. So our p-value is actually 0.038. Now, it didn't change the results we were going to get, although it would have if we were testing at the 0.05 level. Okay, let me write something down, then I'll go back and talk about things. Somewhere you're going to say, T for 5. Where does 5 come from? That's the degrees of freedom. It gives you that. The t-value is negative 2.236. I will tell you a little bit of a difference of opinion on things here, is that in most cases we don't put the negative of a t-value. Usually we wipe it off. I'm going to suggest in this case we leave it because it's one-tailed and lower-tailed critical. If it was upper tail, I'd say take it off. Well, if it's upper tail, it wouldn't be. And my p-value is 0.038. Why is it not significant? Or why is again in plain English, why is 43 not significantly lower than 45, which I don't see anywhere in the output window? Oh, there it is. It's up there. I've scrolled up, yeah. This number right here. That gives the answer to the question. 43 is not significantly lower than 45. Why in this case? Why does that number tell us that's the case? Well, yes, it does. But let me say it's slightly different. The answer is no, it's not significant because P is not less than our alpha level of 0.01. Yeah, you said it's greater than, which is true. You said because it's greater than 0.01? Yeah, that's right. But the way I want to look at it is not, is it less than 0.01? Oh, it's greater than. Well, okay, that answers my question. So we're not saying different things at all. We're saying the same thing. We're just saying it a little bit differently. The question is our p-value less than our alpha level? That's what it comes down to. Is P less than alpha? If it is, it's significant. If no, as bad as I write, this hurts me even worse. If yes, then significant. If no, I did it again. I can't spell the word no. Not significant. And what I'm writing here is if the case is yes, if you get a p-value of 0.00 something, is significant, you reject the null. In this case, the answer is no. P is not less than our alpha level of 0.01, so it's not significant. We don't reject the null. Yes. I'm not going to repeat that, okay. And that's true. That will always be true for all these tests. We interpret things essentially, bottom line, based on the p-value. Now notice something else. And I told you we'd come back to it, and I'd had questions about it earlier. Notice this part, there's our test value. Where does the mean difference come from? It says mean difference is -2. You guys still awake at home? Okay. Yes. And as soon as I say that, I get an answer. Yes. Okay. A mean difference of 2 means our average was 2 below our test value, -2. So that's the difference we found. So what's the difference likely to be? Notice my confidence interval. The difference really is probably somewhere between -5.6 and +1.6. The fact that the difference could be 0, meaning that it's likely there's enough of a possibility that there could not be a difference. That's why we're going to say there's not a significant difference. 0 is in the confidence interval. Rejecting the null, finding significance is also consistent with 0 being in the confidence interval. I'll say it again. Rejecting the null and there being significance, or a significant difference, is also consistent or synonymous with 0 being in the confidence interval. Because what that tells me, well, your difference could be 0. Okay, well, if the difference could be 0, there's not a significant difference in. It means there might not be a difference. Now, that's not critical that you understand that, except that you'll see when we write this up, we generally report the confidence intervals, but it figures it out for you. So does that? 0's in there. Yeah. So that, yeah, 0 being in there is why it's not significant. Other thoughts, questions, comments? Let's do a couple more examples. Which negative are you talking about? Okay, she says never mind. She withdraws the question, Your Honor. Okay, okay. All right. Let's do a couple more examples the easy way. Alpha is preset. I'm testing this at the 0.05 level of significance. We determine what alpha is up front. P-value is what we get on the end. Okay. The test value is the test value is predetermined. In this case, our benchmark was 45 miles per gallon. Okay, good question. Yeah, the question was, is the test value predetermined? The answer is essentially yes. Yeah, that's what you put that in. It doesn't pop out. Well, the reason you use a certain alpha is because you decided to use that certain alpha. Now, let me do a what if real quick. What if we had been using an alpha level of 0.05? I've got the same result, but look what, except for the confidence interval, I've got the same result. But look what pops. How would we interpret an alpha level of 0.5 with these results? Again, what do you look at? You look at the p-value. Okay, so now we're testing it against an alpha level of 0.05, which is what we normally use. So what would you conclude if the alpha level was preset to 0.05? So p is less than the alpha level. So at the 0.05 level, I would say 43 is significantly less than 45. Well, we decided to use a smaller alpha level because the smaller the alpha level is, if you've got significance, the more likely there really is to be what you say there is. And this is going to be a very conservative kind of estimate, because if I'm the government, well, pretending I'm the benevolent government, I'm not going to zap you until I am not just pretty sure, but danged sure that you're below that. In kind of the vernacular, an alpha level of 0.05 is pretty sure. And an alpha level of 0.01 is dang sure. An alpha level of 0.001 is pretty dang sure. Sometimes you use an alpha level of 0.10. The stakes aren't as high. The higher the stakes are, the smaller you need to set your alpha level. If I set my alpha level at 0.05, I'm willing for there to be a 5% chance I'm wrong. But 5% is too much, we decide on this one. I want to make sure there's a less than 1% chance of being wrong. So this is a much more conservative way to look at this. Yeah, let me paraphrase that a little bit. I might use a level of 0.00. Well, yeah, that's kind of the other side. Yeah, that would, and I'm not going to repeat that, but let me just say it this way. If you're talking about the possibility of killing people or not, you generally want to say a very small alpha level. Because I'd rather there be a 1 out of 1,000 chance of killing somebody than a 1 out of 20 chance. But on the other hand, you may want to be real conservative if you're looking at, say, the example you gave was, say, DUI levels. Hey, buddy, there's a 90% chance you've been drinking too much. That's probably a safer thing to do in that case. Yeah, that was your example. It depends. The answer is it depends. Look at Green and Salkand. Let's go to lesson 24 and call up. I wonder if I can get rid of this. I bet I can. Call up lesson 20. Actually, I'm sorry, I lied. Lesson 22. Call up lesson 22, data file 1. It looks like this. Lesson 22, data file 1. And you'll refer to page 163 and look at the second scenario on page 123, the one that says Janet's interested in determining if male adolescents who do not engage in sports are more depressed than others. Lesson 22, data file 1. Find it at home? You should be able to just click on that data set and it should open up in SPSS automatically. I don't know. You may have to go to File and then Open. You can close off that last example with the miles per gallon. I already lost mine. And give you a couple more minutes to get there. Okay, still working on it, that's fine. What did you say? You canceled the wrong one. Okay, that happens. Okay. Find it? Got it at home? Okay. Still lost my I lost my chat window. There it is. Okay, now I found it. Okay, anybody got it at home yet? Okay, a couple people have. Okay, good. All right, people are saying they've got it. All right, so walk with me through the scenario on the bottom page 163. It says, Janet is interested in determining if male adolescents who don't engage in sports are more depressed than the average male adolescent. So we've got the Kansas University Depression Inventory, CUDI, I think that's a real instrument actually, from 30 boys who don't engage in sports, and we're looking at their depression scores. So it's a depression measure that was standardized and all this different stuff. So we conduct a one-sample t-test. Now, if you look at the a little further down the example here, it'll tell you that this on the data set, the values represent depression scores. We know that young male adolescents have a mean of 50. So 50 is the test value. Did I lose you? Page 165, middle of the page. It's in blocks there. All right, so I'm going to go down to Analyze. I'm going to compare means. We're doing a one-sample t-test. So I click that, I open up my window with two boxes. The left box shows every variable we have, the whole one of them. I want to move that to the right box because that's the one we're talking about. What is the test value? 50, because that's the mean. We want to know if our depression scores are different than 50. Does it say what the alpha level is? If it doesn't say, it's 0.05. And I don't think it says so anywhere. So, if I go to my options, then I think I'm going to find the default confidence interval of 95%, which is what I want to use with an alpha level of 0.05. So I'm ready to click OK, and I am told that, and if I can get more of this on the screen here, here's my mean. Oops, come on, Don. My mean, my standard deviation, my t-value, degrees of freedom, and the significance. So, somewhere I'm going to write T for, and where does the 29 come from? Okay, but where does it come from? It's the degrees of freedom. Where does it come from? If you scroll down, you'll saw there were 30 of them, as the problem said. So there are 30 cases, so 30 minus 1 is 29. The t-value for 29 degrees of freedom is 2.457. Now, what's my p-value? Trick question. Well, do I want a one-tail test or a two-tail test? And by the way, the steps in the green algorithm, they kind of omit this part. But we really want a one-tail test because the question was, are these students more depressed? And more gives you direction. Not just are they differently depressed, or are they depressed more or less, are they more? So my p-value is really 0.01. Now, I get the same result because how do I interpret this as being significant or not? Is it below 0.05? And the answer is it is. Even if I hadn't done that divide by 2 thing, I would have still have gotten that. So it is significant. Now, my mean was 54. 54 is above 50. So that means that for these data, then let's go back to what our question was, is that male adolescents who do not participate in sports tend to be significantly more depressed. Because the higher the number, the more depression you've got. I think that's what it says. Kind of makes sense? Okay, so, questions? The question is actually expressed as a statement. The very first part of the scenario at the bottom of page 163, we're determining if male adolescents who don't play sports are more depressed than the average males. So the question is, and actually you've got, let's look under the research question. It's right below the data set when it defines the inventory. Look at the heading research question. Look at the last part of it. Are male adolescents who do not engage in sports? Actually, this says more or less. 165. 165. Green and Salkin book, not the soft cover. Everything from a data set is in the Green and Salkin book. Okay. Okay. Well, let's go over it again. I think we've got a discrepancy in the scenario and the research question. The scenario says, are they more depressed? The research question says, are they more or less depressed? Then we should probably, and I just noticed that just now, we should probably go with the research question. So they are more or less depressed, and specifically this is more because the mean of 54 is higher, so significantly higher than the average of 50. Well, there should be consistency, but we're going to go with the research question. Yeah, it's a two-tail test. Yeah, so we should. I think they intended for it to be a two-tail test, but I think they wrote their scenario wrong. And I didn't notice that till right now. Okay, did I lose some people? Okay. Okay, hang on. I got kicked out of Adobe Connect. Okay, you can hear me. You can't see me.